Hi class, this is course 3, lesson 9, prime numbers. Let's get going. Prime numbers, what are they? Well, they are numbers greater than 1, and they have exactly 2 different counting number factors. Okay, so remember counting numbers are 1, 2, 3, etc. So let's do a quick example. I don't know, let's do the number 17. And the book's going to go through and say, well, if you can only arrange this number into one rectangular strip, okay, then that's prime numbers, and that's on page 55 if you want to look into that. But if you go through your divisibility rules, which we'll get to in just a minute, unless you were paying attention when we did course 2, you'll know that the prime numbers, this number only has factors of 1 and 17. It's the only way you can multiply to get to 17. And over here on the side, I have a nice box that has a very interesting fact. You need to write this down and then star it and underline it and highlight it. The number 1 is neither prime nor composite. Okay, and you're going to have questions about numbers on a number cube and which ones are composite and which ones are prime, and you're going to include 1 and you shouldn't. 1, it doesn't fit either one of these categories. So what are composite numbers? Well, those would be all the other numbers. They're greater than 1 and they have more than 2 counting number factors. So if we use the number 40, we'd be talking 1 and 40, 2 and 20, 4 and 10, 5 and 8. Okay, so this clearly has more than 2 counting number factors. And back to prime numbers real quick. The 2 factors are always going to be 1 and the number that you're talking about. There won't be any additional numbers. Don't be confused when you get numbers like 25, where the factors are 1 and 25, and then 5 and 5. This is still composite, and it has more than 2 factors. 1 and 25, that'd be 2 factors. This one is a third factor because 5 and 5 are the same number. Okay. Prime factorization, we're going to do the prime factorization of 48 by using a factor tree and by division by primes. So I'm going to do both examples, and you pick the one that works best for you. Okay, using a factor tree, we're going to start with the number that they give us at the top, and we're going to do a little arrow, and we're going to put whatever 2 factors just pop into our head real quick. 6 and 8 are the ones that work for me. You could look at this and go, well, I know it's even, so 2. That's fine. The end result's going to be the same. 6. Is that prime? No. So I know that it'll break off into 2 branches, and I know that 2 and 3 will multiply to 6. Now I look at 2, that's prime, so I'm going to circle it, and I know that 3 is prime also. 2 is prime because its factors are 1 and 2. 3 is prime because its factors are 1 and 3. 8 will break down into 2 times 4. 2 is prime, we already discussed that. 4 is not prime because I know that 2 times 2 is 4. But I know that 2 is prime. So the prime factorization of 48, when I do factor tree, I'm going to list this in numerical order. So numerical order. And we're going to put 2 dot, that's the dot multiplier, 2 times 2 times 2 times 2. So there should be 4 2's, and then we're going to multiply times 3. That is the prime factorization right here. This is not. This is a factor tree that gets you to the prime factorization when you write it out with multiplication symbol in between. If you just put a factor tree on your paper and circle those numbers, I will count it wrong every single time. Okay, so now if you remember, this is just an added note. You can also express this repeated multiplication with exponents, so that would be 2 to the 4th power times 3. That's not in this lesson yet. If you do use exponents, I won't count it wrong. Do whatever makes the most sense for you at this time. Division by primes. We're going to put the number 48. They gave us that number, and we're going to put it in a box. And then we're going to start dividing by primes. Okay, well, I know 2 is prime, so I'll divide this by 2, and I get 24. 24 is not prime, so I'm going to divide it again, so I'll put another box. I know 2 is prime, so I'll divide 2 into 24, and I get 12. 12 is not prime, so I'll do this again. 2, 6, I know 6 is not prime. 2 and 3, and I know that 3 is prime. You can do another box and put the 3 out here and then put a 1 at the top, and that's how you know you're done. Or you can stop here and say, well, I know that 3 is prime, so I know that these are my factors, and then again you would list them in numerical order with multiplication signs in between them. Okay, divisibility tests. The course 2 students went over this in class the other day, and maybe you recall some of this, but put this all in your chart or in your notebook. If a number is divisible by 2, if it's even, by 3 if you add the digits up, and that sum is divisible by 3. So if I had the number 120, if I add 1 plus 2 plus 0, I get 3, and I know that 3 is divisible by 3, so 3 would be a factor. A number is divisible by 4 if the last 2 digits are divisible by 4, or if the number ends in 0, 0. So if we go back to this number 120 up here, I would say, well, we're going to use the number 20 because that's the last 2 digits, and 20 divided by 4 equals 5. So 4 would be a factor. 5 should be one that you're familiar with. 0 or 5 have to be the last digits. 6 is one of my favorites. If you have 2 and 3 on the list, like you've already gone through and you said 2 and 3 are factors, and 6 automatically is a factor. 8. You have to see if the last 3 digits are divisible by 8, or if the number ends in 3 zeros. So back here with our example 120, since there are only 3 digits in the number, you would have to divide that out with long division. Number 9 works just like number 3. You add the digits up, and then you see if that sum is divisible by 9. Now, notice there is no rule for 7. 7 is long division. You have to divide it out. There is no shortcut. Okay? So, I want you to decide if these two numbers down here, 1,328,944 and 432,831, are they prime or are they composite? So now what am I asking you to do there? Remember, if it's prime, the factors are 1 and the number itself. They're composite if you can get one of these other numbers, or in sometimes the number might be divisible by 11 but not by anything else. Okay, so you might get fooled on some of those, but typically you're going to be able to get one of these numbers to go into a number that's composite. So check these for divisibility when you figure out whether you have prime or composite numbers. You can we'll pause the video right now. Sorry, pause the video right now. Figure these out. Then when you're ready to check the answers, resume. Okay, so the first one is composite and the second one is composite as well. Hopefully those are the answers you got. So that's all I have for you today. I will see you in class.